Is it
Good
audible?
morning.
Audible? Yeah. Good morning, everyone. Thanks, everyone, for wonderful presentations. So now, as of now, yeah, myself, Venkat Gauri Rajesh, and Shiv Shankar. We both are from CISCO, and both are based out of India. Like, yeah, my team in India kind of predominantly focus on the layer 2 and some of the layer 3 stuff. Over the last 1 year, we did significant contributions in, for the PENS group, and also we did outside PENS group as well. Like to name, like we did some contributions in the PVST, also Team D, and also DHCP before delay, which we are going to talk now. Okay, like, yeah, we can go to the next slide. Yeah, like pretty much like who are working in SONiC from long time will know like how SONiC evolved, right? Like initial days, they kind of taken multiple open sources like and clubbed it together and made it as a product actually. Like ISC DHCP is one among them. Like if you take another example, Team D is something like that, which is taken from some other open source, and SONiC consumed it. Actually, these kind of designs, right, this old code which is like written some decades ago is not really suited for SONiC environment, and also they are not properly integrated into SONiC as well. Like it comes with a lot of baggage, and also it comes with a lot of like scalability issues and flexibility issues as well. Also, like in current designs, right, like what we need is more debuggability and serviceability. Absolutely, these old designs and old code, whatever is there, right, is it's lacking a lot of debuggability skills actually. So what we did is like we kind of taken an approach to completely rewrite the existing DHCP v4 relay code in the community, and we are coming up with a next gen DHCP v4 code. Yeah. Like many of you already know what DHCP v4 relay does. It's a very simple protocol. What it does is like client will be sitting in one side and server will be sitting in another side. V4 relay will kind of establish the connectivity between client and server, which will be, they can be in multiple VLAN domains, also it can be in multiple VRF domains as well. Yeah, and like currently existing DHCP v4 relay in SONiC will only support option 82. That is the very basic option any DHCP relay can support. It also lacks other advanced options as well. Yeah. Yeah, like I will explain the motivation for this work. Like, okay, like ISC DHCP relay is one of the other open source which SONiC consumed a long time before. Now from year of 2022, right, like ISC officially announced they are no longer going to support the DHCP v4 relay code anymore, and also they stopped publishing in their community as well. And right now in SONiC, it has been maintained as a patches. Like if somebody want to do bug fixing or add some features, we have to give it as a patch. And review becomes very painful. Somebody has to take the patch, load it into their workspace, review it, and again approve. And it's also, it will be applied during runtime and build time, which is very difficult to maintain. Second thing is like static configuration. This is one of the biggest pain point we observed. Like as I said, right, like this is written long ago, like two decades ago. Like whenever a new configuration is applied, like suppose if somebody want to enable DHCP v4 relay on one VLAN, Docker goes for restart. If you want to apply for another VLAN, Docker goes for restart. That's the biggest pain point. Just imagine if some upgrade is going on. So we will be applying configuration one by one from either controller or from CLI or any configuration replayer. For every configuration you apply, this Docker is going for a restart. And it's not that like, okay, just imagine everything is stable. Like suppose we have 10 DHCP v4 relays configured, and also some user want to configure for another one, right? Again, it goes for restart. What will happen for the DHCP communication for already existing VLANs? They suddenly see packets are getting dropped, which is not acceptable in the year of 2025 at least, right? It's okay earlier. And second thing is, this is one more pain point we observed when we trying to scale it for web scalers actually. Like, suppose, as I said, right, within the Docker also, for every VLAN on which we enable DHCP v4, it's spawning a new process. Like suppose if we enable for 10 VLANs, it spawns 10 ISC DHCP process. For 50, 50. If it's for 100, 100. Like we kind of plan to scale this for 1500 VLANs. With this current code, we may need 1500 processes. And all DHCP v4 does, it's a small protocol, right? What it does, it just receives the packets from client, add some options and send it to server. That's all it does. Why do we need a server dedicated process for the small functionality? So this doesn't scale. And also it kind of, whenever our system is going for reload, right, we are seeing lot of CPU spikes actually, like many processors are getting kicked in within a Docker for within short duration of time. And it's like repetitive, like first turn 10, whenever already we have suppose 5 processors there, if you are spawning 6th one, all 5 are getting restarted. It's like a cumulative effect. So yeah, then right, one more thing is like current deployments, right, will expect DHCP server to be present in a different VRF domain, and clients will be like located in different VRF domains actually. Like currently natively whatever ISC DHCP code whatever we are using, it doesn't support it. It expects server and client to be in same VRF. There may be some enterprise customers would have solved this issue, but natively ISC DHCP code doesn't support it. It expects both to be in same VRF domain. And coming to the operational complexity, right, like it lacks telemetry support, it doesn't have enough logs, also it doesn't have counters, native counters by itself, like what other people are doing, like they're kind of spawning some pseudo processes to monitor and tap the packets, and those counters are being written to CounterDB, but they are not really coming from the real DHCP v4 relay code. So this is the main motivation for our work. So my colleague Shivashankar will explain how we solve this one.
Yeah, thanks Rajesh for setting up the context. So now we'll see how we have overcome these drawbacks of ISC DHCP relay. So since we have written this from scratch, so basically this is a single process. Any n number of VLANs, there will be only one single DHCP relay process, which will be catering the service for all the VLANs configured for the DHCP relay. And with this, we remove the overhead of restarting the process every time when a new configuration comes in, right? So we have brought in the support for config manager, which will subscribe to your SONiC DB updates, and as and when you configure it on the fly, the configuration gets applied and you have your service ready. And with VRF awareness, so with ISC DHCP relay, as Rajesh was explaining, so we have to spawn the DHCP relay process in that particular VRF context or in that NetNS. So that we don't have to do that now, because we since it's a single process, and also we have the control over the soft forwarding, so we can inject the packet in which VRF we want. Basically, if the server is reachable via different VRF, we can inject the packet there, or vice versa for the client, right? So client side, if it's a different VRF, we can inject the packet there. So that's easily taken care in this new process. And coexistence with the present ISC DHCP relay. So there might be already many deployments where people would already be using ISC DHCP relay. So we are not going to disturb that right away, because even with this feature present, the DHCP relay will come up with ISC DHCP relay, but we have introduced a knob where if you enable this feature, only then our new feature will kick in, and all the tables will be migrated, and you will have the same CLIs which were designed for the ISC for config or show CLIs. We are still applicable here. Basically, they just start behaving differently once you enable the feature. So you'll have a different outputs and data available for the display. And yeah, with this one, so with respect to coexistence, so as Rajesh was telling, so there is a third part. There's one more process which was developed for SONiC to monitor DHCP relay. Basically, whether is it behaving properly. So it again taps for the packets and then validates it. So we have made sure we qualified for that as well, because that also keeps running in present deployments to validate whether the DHCP relay functionality works properly. So those counters and DHCP monitor is qualified for this new relay process as well. And enhanced option 82 processing. Yeah, we have supported some additional option 82 sub options for the present deployments of EVPN, VXLAN, SAG use cases. So I'll be covering them more in the next slide. There's a feature work which we'll have to do for the REST and GNMI API exposure. And with respect to the forwarding logic, yeah, as I was telling earlier, so since we have the entire view of the SONiC DBs, and since it's a native SONiC application now rather than a third-party application, you have the view of entire SONiC DB, and you are subscribed to the updates, hot updates. So you know the VRF updates, interface updates, and if you're going to use a loopback for the relay, so you have the updates, everything. Based on that, we take the forwarding decisions. Yeah, moving on to the next slide. So circuit ID and remote ID are the default sub options which even ISC DHCP relay supports. There's not much change with respect to that in the new process as well, but the new sub options which we have supported are link selection. Basically, in large cloud scale deployments, obviously one relay server will not be catering to one particular VLAN, right? It will have configurations for n number of VLANs, but you would want to just expose one particular IP for that relay agent. So you will have to configure the source interface. It might be a loopback or anything. So you'll just have one interface exposed towards the server, but you need a way to convey to the server that from which pool it has to allocate the IP address, right? That is where this sub option will come into picture. So you just specify the pool from where the server has to assign the IP address. That's where link selection will be useful. Coming to server ID override, this is a sub option will mostly be useful for the clients. Basically, for every renewal, clients don't have to send the packet directly towards the DHCP server. Basically, when this option is enabled, we replace the DHCP server IP address in the DHCP packet with the relay IP address, so that client can send the packets directly to the relay instead of sending to the server directly. So that we have more control over the renewals as well, right? Who is renewing the IP address, from which client is renewing? Basically granular control, and you can put your policies based on that. So you have a single control without seeing all the clients sending the packets directly to the server. And with respect to virtual subnet identifier, so with lot of VRFs coming into picture, obviously nowadays DHCP servers have been configured with pools with respect to your VRF. So one VRF can have multiple VRFs can have bit of overlapping subnets as well. So DHCP server needs to take a conscious decision from which pool and from which VRF the IP address has to be allocated without cross allocation of the IP address from a different pool. So that's where this option will be helpful. Basically, you inform the DHCP server about which VRF. So this sub option has multiple options. You can carry the VRF name, ASCII value exact VRF name, or you can have the exact VPN ID, unique identifier for that VPN ID to match on the DHCP server side. So with all these sub options, with respect to the testing of these things, right? So ISC DHCP relay already has pretty good test coverage with respect to SONiC management. So we have qualified all those cases for this new process as well. Along with that, there are some additional test cases which validate these new sub options to make sure we are on par with that, and then support the other additional test cases. Yeah, that's about sub options. So yeah, these are the use cases which I was again touching upon in the previous slide. So which are actually which make use of these new sub options. We have validated them and they work fine. With respect to eVPN, you can cater these services for overlays and even underlays. You have multiple VRF scenarios where you can use your link selection, source interface, and also VSS sub option to exactly communicate which IP address needs to be assigned from the DHCP server. In case of static Anycast gateway, again you have one fixed IP, so you can use your source interface just to inform this is always going to be relay IP address for the server instead of having a different IP address per VLAN, right? So, and with respect to unnumbered, in the topologies where we have IPv4s with IPv6 next hops, again with reuse of these sub options, again you can still specify which IP address the server has to reach and vice versa for the relay, even though the next hop is IPv6. Yeah, this has been evaluated with respect to this new process. Yeah, this is the roadmap for the new set of work which is going to come with respect to relay. DHCP v6 relay in SONiC today is also written for SONiC, but it doesn't have enough sub-option support or the config manager support. Even this process, even though it's a single process, it has to be restarted every time once you configure, because it doesn't have a config manager. It is not intelligent enough to read the configurations then and there. It has to read only during the init of the process. So yeah, and it has, we'll bring in the modular sub policies for the sub options and VRF support, and then future extensibility for this particular option. Yeah, so transitioning to this DHCP relay brings in a lot of major improvements with respect to present deployments, where you don't have to worry about too many processes getting spawned and one particular single process taking care of all your DHCP relay needs. This enables your cloud scale deployments, multi-tenant deployments, right? Dynamically configurable networks without any drawbacks which we were facing with the ISA DHCP relay, and limited to use it in a particular way rather than using it very dynamically. Yeah, so our recommendation is people can adapt to this and migrate based on the need. So we have one small pre-recorded demo just to show the end-to-end functionality. Yeah, some of us will like more if we see the packet level details. So I have tried to add some Wireshark captures. Let's see. Yeah, so this is the basic IP class topology we used, where server is reachable through a different VRF and the client through a different VRF. Is it playing?
No, press that red button.
Okay, it started playing now. So this is what we have simulated in our lab for this quick demo. Yeah, we were just dumping the configuration on the leaf 0 side where we had the DHCP client configured. You could see that server is reachable on the VRF 02 side, and VLAN on the client side is on a different VRF. So this command is same for the ISA DHCP relay as well, but just that the outlook changes once the knob is enabled. So we have all the sub options enabled with server VRF in a different VRF and the loopback used as the source interface. Yeah, going to the leaf 1 where the DHCP server is configured. Here it's on VLAN 20. The server is on VLAN 20, different broadcast domain than the client side. So simulated with client and server on the XIA. So you have your pools configured. We have just reduced the lease time to 60 seconds just to show the renewal happening as well. Yeah, server IP which has been displayed, and there are 2 client devices created, just enabling the capture just to see the sub options what we have supported to have a more in-depth view of what is being sent and received from the client and server side. Yeah, just we start the test and then it's done in a second, and the clients got IP addresses allocated. You should see 2 addresses allocated because we have 2 devices created there. Yeah, so and then so we have also implemented in-house DHCP relay counters. It's not from DHCP Mon, but in-house DHCP relay process counters on per VLAN basis. So you know how many clients are actually interacting for basically with the relay for the IP address. So we have TX and RX counters for this, and also we have extended it to malformed and drop packets just so that it helps in our debugging. Otherwise, it's difficult to understand where the packet got lost. And yeah, we can stop this test, and renewal should have been completed. And we just see the display of the packets on the server side first, just to understand what sub options have been carried. Yeah, so here we see that relay agent IP address is so loopback IP 2.2.2. It's not the VLAN IP, and the sub options which are carried are link selection, server ID override, and the VRF name, So we carry the subnet where the IP address has to be allocated for the link selection, and then the IP address of the VLAN for the clients for the renewal, which will be inserted as a DHCP server IP address. And the VRF name, yeah, so this is option 1, 0, where we encoded the VRF ASCII name for the DHCP server to decide based on the pool and the VRF configured for that pool. Yeah, for the client side, so you could see that DHCP server identifier has been replaced with the relay IP address. So for any renewals to devices which were created, the renewals were sent to the 10.1, the relay IP address, instead of directly sending it towards the server. Yeah, this serves the purpose of sending it to the relay rather than to the server. Yeah. Yeah, this is about the demo, and HLD is already merged for this PR, and the code PRs are just out. Yeah, people can go and take a look on them. Yeah, that's about presentation. Have any questions, we can take them now.
Hi, I'm Raghunath Reddy from Microsoft. So do we have the DHCP v4 relay with the stateful also to install the type 2 MAC routes and all? Type 2 routes in the EVPN with MPBGP. Is it supported now?
No, it shouldn't matter for the DHCP relay, right? Yeah.
No, actually there is a use case we implemented in iOS XR 2018.
Okay.
You can install type 2 MAC routes. That's a real use case. You can think of that.
Type 2 as in for the VSS you are telling?
Whatever the address allocated for the user, that MAC versus IP address allocation, you can install the route.
Okay.
That's one of the use case.
Okay.
Yeah,
Maybe
it should be supported because like from the control plane, right, we just inject from the software into the kernel. So kernel will take care of all that stuff.
No, iOS XR supports it.
Yeah, this should support natively.
Okay, sure. Another one is DHCP snooping also you are planning to?
No, it's not right now in the roadmap. First, we are planning to focus enhancing the DHCP v6 portions, and we want like community to consume and provide the feedback. Based on that, we'll proceed with it.
Okay.
Yeah, if some specific ask is there, well, please feel free to ask.
Yeah, I think that is also another use case with the EVPN.
Okay.
It's iOS XR supported.
So we'll note down. So you are from Microsoft, right? Definitely.
Earlier I worked for Microsoft. Yeah.
Okay.
I mean, so earlier I worked for CISCO.
Okay.
For 16 years. And
definitely, if it's coming from you,
Microsoft.
we'll do it.
Sure.
Yeah, I think there's one.
Hi.
So nice presentation. So what drove you to write afresh? Did you consider other open source implementations? There's Kia DHCP and so ODHCP. There are multiple of them.
Yeah.
So which feature drove you to write afresh?
Yeah, Kia also is a primarily, see, if you take ISC also, right, primarily they started as a server. Then they kind of tweaked the code for relay. Kia also primarily is a server actually. And even if you consume that code, we end up writing the configuration manager part. Like, so we have to listen to the configuration updates from the CLI or YANG. We need to take care of maintaining the process intact and push the configuration updates, and we have to tweak that. Even Kia also, like we have checked it, it is not natively supporting the telemetry, enough counters also. Like everything is a problem, right? Even if you take Kia, somehow we have to again patch it to support the counters, again patch it to support the like logs or whatever it is. And we end up again, like VRF support also, we end up adding on top of the existing code. So we felt for SONiC deployments, this is enough, like, and this is the better way to implement actually.
Okay.
We didn't consider about Kia actually. That is the first question we got it when we published the HLD to in the community from Microsoft. Like we had a discussion and we agreed upon this approach actually.
Okay, thanks.
And to add, right, even DHCP v6 is natively written for SONiC actually. We are not consuming any open source code.
Okay.
Hello, do we have more questions? Good. I think it's
Okay.
okay. Good.
Yeah.
Hey, thank you. And, I mean, so for, we have added a follow.
Sorry to interrupt you.
Okay.
What we will do, we'll take a break. Can you please discuss your question with him?
No
Because we
problem.
are running a little bit late.
That's okay.
Okay. So everybody will take a break. Tea, coffee is ready. And we'll come back by 12. And we'll start our 12. Okay?
Okay, thank you.
Thanks everyone.